Hello everybody and welcome back after a long break. I had a strong flu, so I had been recovering, and even though it's now 2024, I'm getting back to the remaining problems of Advent of Code 2023 so that I kind of get this over with and finalize it. So today we'll be looking at the problem number 17, or the problems of day 17. I've already pre-read the description, so I have some idea how I will try to solve it. But just to summarize it, we have a two-dimensional map where we're trying to find a shortest path, or a path which contains the lowest total of numbers that we encounter from the top left to the bottom right. And the problem that makes this a little bit more complicated is that we want to make sure that we move only at most 3 times in one direction. So if we move 3 times in one direction, we need to switch to 90 degrees and then continue again. So we can move at most 3 times in the same direction. So that's the tricky part of this. So my plan for this was to use Dijkstra's algorithm in a modified way, so that I can kind of take each node on the map as a different node if we encounter it in a different direction or with a different number of preceding steps. So there'll be like 2 different ways where the node can differ. So what I will do is I will create a record which will be called node, and I will use its position. Okay, let's see. All right, point is going to be its position. We will have point direction, and we will have also direction steps. So it's going to be number of steps that we've done in that specific direction, and then we will be using, well, read the map. So input, yeah, exactly. File read lines. I will do width equals and height equals count, and I will do read all lines. It's better, so length will be this, and 0 will be the width. Now we'll have a map which is going to be a new int with height, and I will do for kind of go through read in the map. So for y 0, I will do for x equals 0 to width, and then where is it compiled when I need it? Map xy equals xy minus 0. So this way we'll read in the map, which is going to be, right, it's going to be yx. All right, so then when we read in the map, we will be kind of tracking the min distances for dictionary node and int. So this will be a dictionary that will contain the minimum distance for a given node. And what I want also is to track visited or closed, which will be a bool with height, and we will track here which nodes we already closed, as we no longer need to try to minimize their distance, because we already know that that's the best possible distance that we can reach it in. So that should be it, if I'm not mistaken. I think or is it right? I'm not sure. Let's adjust this later. So min distance is so ideally for the first node we will do for the 0 0. I want 0 0 in distance of 1 1 0 0 1 0 0. So this is like the initial distance, and now while true, we will go through the list and find the lowest possible one. So node equals, yeah, we'll take the one with the lowest distance. Now we remove that one, as we no longer need to process it. And now we will try to go in multiple different directions. So node will be the distance. No, it's not weight. It's total heat. And now let's call this one current node, and let's do var direction and var let's see, position, yeah, and direction step. So just read out all the values. And now what I will do, if I'll try to go to multiple different directions. So if direction steps less than 3, then I can go in the same direction still. So try next node in the same direction, direction steps +1. And I can also always turn left or right. So left turn, try next node, direction left turn, and it's gonna be with 1 step, and var right turn, it's gonna be this, and try next node right turn 1. So essentially I try the different next nodes. So void try next node, and this method will do the following. First, I check if we are within the map. So that's very important, because if we are trying to go outside, or like next position, gonna be position. So we verify that the next position is valid. So point direction in steps. And now if the direction is valid, then we check if we can improve the total, so the next total. So if min is if we never encountered this node yet, if it doesn't contain that key, then we will have to edit, and we also have to edit if min distances next node is greater than next heat. So in that, if we have if you do that, then we add it to the min distances dictionary, and that should be it. If I'm not mistaken. So is there anything else that I need to do? I'm thinking this could be enough, but I need to stop that loop. So what I can do is, if a current node a position equals width -1 height -1, and that moment I output the total heat. And let's run this, see what happens. 102, that's correct. That was okay. So let's try it with the big input, if this will still work or not. Okay, this is taking longer for sure. So how many min distances? Okay, 13,000. So let's let it run to see if it finishes. Okay, so where are we? So let's see, min distances, max, and value, or key position x. $64, and width is what? 141. So there's still a lot to go. I'm thinking if we're not preventing going back in the loop. So we are, it's possible that we are doing something like this. We're going back to this point, even though it is never useful. It's not useful to do that. But no, this check should prevent it. So, well, this check should prevent us from going back. Oh, right, that's pretty important. What I'm doing is I'm removing the smallest one, and I need to make sure that I don't remove, I do visit it, which is gonna be hash set of node, and I make sure that I don't visit something that I already removed from the min distances. So add min node. So I need to make sure that whatever I already processed completely, I remove and do not try to enter it again. So So if we already visited it, right, right, let's do it like this. So if this contains next node, we just stop. That's much faster now. Okay, so 1099, and that is correct. Okay, so we have the first part solved here. So now let's go to the second one. And in the second part, the difference here is that we have a minimum 4 blocks that we have to move in a given direction, and then a maximum of 10 moves in that direction. So it's kind of limiting the way we can move. Also, let's try this one. I'll put it here. Okay, actually I will put it into second lane here and take the input. And now what I will do is kind of modify this logic here. So let's do const and min move steps equals 4 and const and max direction steps is 10, right? So it's 10 and 4. Okay. So if direction steps is less than if direction steps is less than or min direction steps, or I mean greater than at least 4, so it's maybe like this. So basically we can turn only if we've already done at least the given number of steps, so greater than or equal, and if it's less than max direction steps, then we can move forward. So if I'm not mistaken, this should be it. Yes, hopefully yes. So let's see what happens if I run it against the sample input of this. 47. Okay, so not completely. Okay, so there is also a projection that I need to make 4 steps before I reach the end. If the position is and current node direction steps greater than or equal min direction steps. 71. Okay, that's fitting. So now let's try on the second input just to verify. $94, that seems okay. So if I am not mistaken, this could actually work. It's processing. Or is it? I don't see the debugger, but hopefully it is. Okay, so it seems to be processing. It's for sure taking longer. and it's 1266. And that is correct. Okay, so we have solved day 17 of Advent Code 2023. It was kind of tricky one, but as long as you read the description correctly and don't make too many mistakes in the logic, it worked pretty well. So I thank you for joining this day 17 solving session. I will do another video of ChatGPT trying to solve this problem as well. So we'll see how it fares against Dijkstra and a more complicated rule set. And yeah, thank you again. Have a great day. Keep coding, and please subscribe if you want to get notified about my future videos, because I'm planning a lot of content regarding .NET, regarding cross-platform application development and everything. So make sure to subscribe if you want to get notified about those. So thank you and see you next time. Bye bye.